Tomorrow, Ontario is set to release new projections about what's coming. Premier Doug Ford has said the picture is so dire, he says you'll fall off your chair when you hear it. Yet he is waiting to impose tighter public health restrictions. Abigail Beeman has our top story on what's driving the surge in cases and what must be done to slow it down.
Everyone knows about COVID-19 and the steps we have to take to try and eradicate it. But one of the most underrated aspects is actually looking at different ways we can diagnose it. This is where CRISPR comes in, specifically CRISPR-Cas13. Before we dive into how we can change the way we actually diagnose this virus, let's take a look at how we currently diagnose this virus. And we use a method called RT-PCR, or reverse transcription polymerase chain reaction. And so COVID-19 is an RNA virus. And so the first thing we have to do when we're actually trying to diagnose this virus is reverse transcribe it into DNA so that it can be more easily detected by the mechanisms we're going to use. This process of actually turning the RNA into DNA is called amplification. After this, the DNA is then tested to find the COVID strand that it's looking for. So obviously, this method of testing for COVID works, but there are a few problems with it. And one of these problems is the time it takes to actually get the results back. And so companies like Sherlock Bioscience is actually using CRISPR to try and speed up this process and make it a lot more efficient. If you don't know already, CRISPR is this fantastic new method we are using to actually genetically modify organisms and specifically our DNA. And so with this technology, many thought that it was only going to be used to actually genetically modify people, animals, anything that's living. But what we found is that if you're able to be creative and use this technology in different ways and continue to keep researching, it can be used for a variety of different things, including diagnosing. So, Sherlock Biosciences created something called Sherlock, which actually stands for Specific High Sensitivity Enzymatic Reporter Unlocking. This uses the Cas nuclease Cas13, which is different from the regularly used Cas nuclease of Cas9. So, what's the difference between Cas9 and Cas13? Well, in short, Cas9 is going to be cutting DNA and it's going to be looking for our DNA. But Cas13 is actually focused on RNA and looking for RNA. And as I've already mentioned before, RNA is completely different from DNA, as DNA is what is going to be transcribed to actually form RNA. And of course, COVID-19 is an RNA virus. So after the sample is collected from the patient, similar to PCR, the next step of actually using this Sherlock method of diagnosing patients is amplifying the RNA that they have into DNA. And after they amplify it, they then reverse transcribe it back into RNA so that it can be detected by Cas13. So as you can see from this graphic here depicting Sherlock and another method called detector, after we get the sample from the patient, which is as RNA, we're going to first reverse transcribe this into DNA using LAMP, which is an isothermal amplification process. After that, once we get the DNA, we want to actually transcribe that back into RNA so that can be detected by Cas13. And through doing this, we're going to use something called the T7 transcription polymerase. So what's really interesting is that because of LAMP, we can actually do this entire process of diagnosing patients for COVID-19 at a single temperature, which hasn't been seen before and makes it a lot easier for people to access. So after it's been amplified and then re-expressed as RNA, the next step is actually getting quantifiable results. And this is where the Cas13 really shines. So after the Cas13 is inputted with a guide RNA and is looking for the sequences it can find, which I'm going to talk about more later, it's actually going to be activated, which means it's going to become fluorescent, which means that it's going to be very easy for the worker or the person diagnosing the patient to actually find the results based on a little strip they're provided with, which will have a line indicating whether or not they are tested positive for COVID-19. You can think of this final result very similar to a pregnancy test, making it very easy for people to actually use at home. So they're actually going to be looking for two genes to detect to find if people actually have COVID 19 or not. And this is the S gene and the ORF1ab gene. And so the S gene is also known as surface glycoprotein. And in COVID 19, it's responsible for giving it its shape that we all know as a crown, basically, because it looks so much like it. Then we also have the ORF1ab gene, and that's responsible for encrypting two polyproteins called PP1AB and PP1A. And these are actually responsible for allowing COVID 19 to replicate. In this graphic here, you can actually see the genetic sequencing for ORF1AB that I use through Benchling, and I'm hopefully going to be explaining more about in a future video. Thanks for listening, everyone.